Hello guys, welcome back to my channel. Today we will learn Dijkstra's shortest path algorithm for finding the shortest path from a directed graph. So let's move on to the example. Here the question is, find the shortest path from source A to all other destinations in the graph using Dijkstra's algorithm. So in the first step, we just only know the distance from A to A, which is 0, but we don't know the shortest path or the distance to reach B, D, C and E. That's why we put infinity in all other places. So we should write here 0 and all other places is infinity. Now, among all these possible values, the minimum one is 0. That's mean A. Now from A, we can directly move to B, and it takes the distance 10, which is the smaller than the infinity. So we should update this distance. So in B, we should update this distance to 10. Now from A, we can directly move to place C, which takes the edge value 3, which is smaller than the infinity. So we should write here 3 instead of infinity. Here in graph, we cannot directly move to vertex G or vertex E from A. That's why we should not update these two values. Now, among these four values, the minimum one is 3. That's mean the vertex C. So we are here, and from here we can directly move to E, which takes the edge value 2 and its own value 3. So 3 plus 2, it will be 5, which is less than the infinity. So we should update this value with 5. Now from C to D, we can directly move here. So it takes the value 8 and its own value 3. So 3 plus 8, it will be 11, which is the small than the infinity. So we should update this value with 11. If we look at the figure, you can see that we can move to C from B with values 4 and its own value 3, which is 7. And this value is smaller than the previous value 10. So we should update this value 10 with 7. And remove the previous path from A to B. Now, among all three distances, the minimum one is 5. 5 means we are in place E. From E, we can move to D. It takes the path value 9. So 9 plus 5, which is 14, that is the larger than the 11. So we should not take this value and we should not update this value. And we cannot move anywhere in this graph from E. So we should not update these two values. So those values are 7 and 11. Now the minimum among these two is 7. Means we are here in B. So from B we can move to D, which takes the value 7 plus 2. So total 9, which is smaller than the 11. So we should remove this edge. Now the minimum value in this node is 9. So we should update this value with 9. And in next step, the minimum value is 9. That's mean D. From D, we cannot directly move anywhere. So we can move to E, but it is the larger value than the 5. So we should not take this. So we have done this example, and we can say that from place A to place B, the shortest path is 7. From place A to place C, the shortest path is 3. From place A to place D, the shortest path is 9. From place A to place E, the shortest path is 5. Even we can write the path. For example, what is the shortest path from A to D? Which is A to C to B to to D, because the shortest path from A to D is this way. This one, then this one, then this one, which takes the places A to C, C to B, and B to D. Let's look a real life example. Here there are 7 places, and we have to find the shortest path from a source place Agargan to all other places in this graph. So we know the shortest value from Agarga to Agarga is 0. However, we don't know the shortest path yet in other places. That's why we should put the infinity in all other places. So here should be 0 and all other places should be infinity. Now among all possible values, the smallest is 0. That's mean we are here in Agarga. From Agarga we can directly move to farm gate, which takes values 10, which is smaller than the infinity. So we should update this value. And from Agarga we can move to Shamoli, which takes values 4, which is smaller than the infinity. So here in Shamoli we should write 4. Now we should not update all other distances, because we cannot move directly from Agarga to all other places. Now among all available distances, the minimum one is 4. That means we are in Shamoli. From Shamoli we can directly move only one place, that is Asadgate, which takes values 4 and 5, which is 9 and is smaller than the infinity value. So we should update this value, and we should not update all other values because we cannot move directly to all other places. Now among all these values, the minimum one is 9, which is Asadgate here. So we are here. From Asadgate we can move to Farmgate, which takes value 9 and 3, which is 12. That is the larger than the 10. So we should not go in this way. However, from Asadgate we can move to Ajimpur, and it takes the value 9 plus 15, which is 24, which is less than the infinity. So we should update this value, and all the values remain same. Now the minimum one among all these values is 10. That means we are here in Farmgate. From Farmgate we can move directly to Shahabag, which takes the value 5. So 5 plus 10, which is 15, and less than the infinity. So we should write here 15 instead of infinity. We cannot move anywhere in the graph directly from Farmgate, so we should not update these two values. Now among 3 values, the minimum one is 15. That means we are here in Shahabag. From Shahabag we can move directly Buet, and the total distance will be 15 plus 6, total 21. So here we should update the infinity value with 21, and we should not move anywhere, so we cannot update any other values. Now from these two values, the minimum one is 21, that is Buet. From Buet we cannot go anywhere directly, so we should not update any other values. Now the next minimum one is 24, which is Ajimpur. From Ajimpur we cannot move anywhere, so we have done it, and the minimum distance or the shortest path from Agarga to Farmgate is 10, from Agarga to Shahabag is 15, from Agarga to Shamoli is 4, from Agarga to Asadgate is 9, from Agarga to Ajimpur is 24, from Agarga to Buet is 21. Now even we can write the paths, the shortest path from Agarga to Buet, which is Agarka to Farmgate, Farmgate to Shahabak, Shahabak to Poet. In this way, this is the shortest path to reach from source Agarka to the destination Poet. So try yourself. Here is another real life example. A delivery man wants to deliver products to 7 places. Let the delivery hub located at point hub here, and all other places are here with distance given. So you should pause this video and try yourself. You should write your answer in the comment box. I will reply right away. I think you have understood the Dijkstra algorithm. Still, if you have any question, please write in the comment box. I'll try to answer all of your queries. Thank you very much for watching this video. Please like, comment and subscribe my channel.